Manager of the ACP EU Development Minerals Program with UNDP, the United Nations Development Program. Really great to be with you this week and talking about the environmental challenges associated with the mining and extraction of minerals, oil and gas. We have some great questions that have been sent in this week. I think there's about 6 or so questions. I'm going to go through each of them, and thanks very much for sending those questions. It really allows us to kind of have some good interaction and feedback as a result of the modules that we've run in the program this week. So the first question that has been sent in is on a really interesting topic on thickened and paste technology in mine tailings. So you remember during the MOOC modules, we talked about this process of thickening and turning the tailings, the waste material from the crushing and mining and processing of metals into a thicker paste-like waste that tends to be more stable, tends to be more inert, and can save particularly water inputs into the mining process. So the question we have is, could the 2 main reasons for the slow change or the slow uptake of paste and thickened tailings be the increase in cost to the operator and the increased use of energy emissions? It's a very good question. I mean, the first thing that I must say when you answer a question like this is really the performance of any different technology system is going to be dependent on the local conditions, the commodity that's being mined, the geochemistry, the hydrology of the area, the rheology, which means the way in which the waste material performs, and a host of other different factors. But in general, paste and thickened technology obviously has water savings, because what you're trying to do is take the water out of the tailings waste and then transport it in a thicker form. But it can also lead to some energy savings in some systems or some slight energy increase in other systems, depending on the amount of thickening and all the other factors that we talked about earlier. There have certainly been a lot of studies on this, and it's not clear that the paste and thickened tailings is a high energy user compared to conventional tailings. In fact, when you think about it, what you're actually doing is pumping the tailings to a smaller area than you would in a tailings dam. So you're pumping the tailings perhaps a shorter distance and to a more confined space. And you're pumping less of the tailings because the volume of the tailings that you're moving is lower. So you can have some energy savings from configurations like that. But you are pumping something that's more dense. So different studies have come up with different findings, but in general, it's not the energy increase is not a very large factor in the uptake of these technologies. The biggest factor, to my mind, is that we really have a higher technology risk because you've got a novel technology, and that tends to be the reason why some companies are being slow to pick up on the technology, and also that not enough people know about the different options that might be available that might suit different circumstances. I would point you in the direction of looking at the paste and thickened tailings literature. There's some really great works now. Particularly, there's a book called Paste and Thickened Tailings that's been edited now maybe 3 times by Richard Jewell and Andy Fourie from Western Australia. I'd encourage you to look at that. There's some good findings in the edited volume, in that particular edited volume. In general, when it's related to costs, the costs are also variable, but what tends to happen is that the CapEx cost, the cost of the capital for these new technology systems tends to be higher than conventional tailings, but the operating cost can be a lot lower. And remembering your perpetual costs, so conventional tailings dams need to be perpetually managed because of the potential for drainage from those dams, especially if you haven't got the studies right. The cost over the long term can be much lower under a paste and thickened tailing technology system. You also potentially have lower risk of catastrophic failures of tailings dams which can cause catastrophic costs. If you think of San Marco, the jointly owned BHP and Vale project in Brazil, the tailings dam failure there released 32 million cubic meters of iron ore waste into the environment, and the costs associated with that are catastrophic. So there's a balance between the capital costs, the operating costs, and the long-term risks that might come from failure of conventional tailings dams. Okay, so our second question is on metallurgical coal, and the question is framed in terms of innovations in renewable energy as well. So the question goes, can steel for windmills be made using other substances besides metallurgical coal? Is the extraction of metals also a significant factor or contributor to climate change? And because metals were not mentioned, and perhaps they're not trying to phase out the extraction of gold, copper, and other precious metals, as the world will continue to need more. So this is an area that there's been some really interesting research into. For those that don't know the difference between the two main forms of coal, metallurgical coal is hard coal, sometimes called coking coal, that is used for the coking and production of steel. So iron ore is put in a furnace with the metallurgical coal, and you get steel. The other form of coal is thermal coal. That's coal that tends to be of a lower grade and is used for the burning to create electricity. Thermal coal and metallurgical coal have principally two different markets, different prices, and even though there's been obviously a lot of pressure on the thermal coal market in relation to climate change, metallurgical coal, there are some questions about whether, in fact, we can substitute metallurgical coal in the way that we can substitute thermal coal. So thermal coal, you can look for alternative energy sources. Metallurgical coal is much harder to substitute. So I think that there's a strong case for metallurgical coal still being an important component or commodity, even when we think about development from a sustainable development perspective. But there's been some really neat and interesting research that's looked at the role of replacing that metallurgical coal with other forms of charcoal produced from biomass. Biomass has its own challenges in terms of environmental impacts, but the kind of biomass systems that they're talking about for replacing metallurgical coal are things like pine plantations, scraps from pine plantations, so the biomass that's waste after you've produced the wood products and the pulp products that you need. And also an interesting innovation in Australia, they've been talking about the potential to grow mallee scrub, which is a kind of native vegetation, in areas of high soil salinity. There's problems in some parts of arid Australia where the water table has been rising due to the land clearing that's happened at the surface, bringing with it salts and then causing that land to be non-productive for agriculture. So people have argued that perhaps you could grow these mallee scrubs, the vegetation that would have been there in the past, that would lower the water table, and you could harvest the scrub for production of charcoal, then used to coke steel, iron ore for steel. There have been some good studies by the CSIRO, which is Australia's kind of scientific government organisation. They have looked into the different configurations. In fact, we did some work for the CSIRO on this topic, trying to look at, well, what are the social and environmental implications of different models of coking for steel. So we looked at metallurgical coal, we looked at biomass from pine plantations, and we looked at biomass from mallee scrub. So it's still a very infant area. It hasn't been implemented at scale, but there are some opportunities to replace metallurgical coal with biomass that might lead to some sustainable development outcomes. On the second part of the question around the contribution of the metal sector to climate change, definitely the mining of metal is energy intensive. What we're talking about mainly is the energy that's used in the crushing of ore. That tends to be one of the biggest components of energy use in the mining industry. It's called comminution. It's basically crushing the ore so that you can then further process it and extract the metal. I talked about in the module the issue of declining ore grades is a big factor in production of energy, because as ore grades are declining, the amount of rock that you need to mine to get the same amount of commodity is increasing, and therefore your energy costs potentially will also increase. So that can have an impact, obviously, on efforts to reduce energy consumption. We do see, though, that some sites are trying to at least supplement some of their energy production with renewable forms, not for comminution, but more for running other aspects of the mine. Chuquicamata, the largest mine, hole in the ground in Chile, it's been going for over 100 years. They supplement their electricity with solar PV. There's also been mine sites that have looked at using solar thermal as well. So there's different ways in which you could produce energy that could assist to reduce the amount of emissions associated with the mining of metals. But some of those really energy-intensive forms of energy use on a mine site, like comminution, may still need some kind of a baseload power. The next question is around the economic pressures and limited awareness of the effects of contamination arising from mineral and oil extraction and its effect on public health in Africa. And the question asks, what measures can be adopted to ensure transparency and promote the establishment of monitoring mechanisms to benefit local communities and enhance sustainable development? It's a good question. It's a question that we have a lot of answers for. The last decade and a half, maybe more, there have been a lot of guidance products, knowledge products, standards, principles developed that get at the heart of governance of mining and oil industries. And so there's not a shortage of information available, or tools or approaches that would deal with some of these challenges that you've been talking about during this MOOC. To give you an idea of some of the things that can happen on a mine site that might, or an oil and gas facility that might lead to better environmental and social outcomes, we have impact assessment that's been around for a long time. We have management plans that nowadays aren't just for environment, but are also for social, also for human rights, also for looking at resettlement action plans, or there's a whole range and proliferation of the use of management plans at the site level. There's been also a drive for agreement making between mine sites, oil and gas facilities, and local communities and local governments. And that agreement making process can draw from impact assessment. What are the issues that are really potentially going to be arise as part of this project? How do we address those together, and what kind of resources are available to make sure that we monitor and continue to get good outcomes? So there's certainly been a lot of new forms of governance that aren't just the typical government and company relationship. We have participatory monitoring that's happened, a lot of participatory water monitoring, particularly in Latin America. There's been dialogue tables and dialogue processes in many different countries, and those kind of almost a movement of dialogue tables, particularly in Latin America, that are innovating in this area. We've also got grievance handling processes and complaints handling processes. So there's a very long list of different things that have been suggested and implemented at different sites to varying degrees of success. The major institutions in the mining and oil and gas sector have kind of adopted and supported these things. The International Council for Mining Metals, IPICA on the oil and gas side, they're the peak bodies that have been putting out guidance products that speak to all of these issues. We've got the IFC performance standards. We've got governments like Australian government has a whole handbook series on all of the issues in mining. I think it's like 12 or 14 handbooks that are really detailed and have very good advice on how to deal with these challenges. We've got institutions like the Sustainable Minerals Institute at the University of Queensland and the Centre for Social Responsibility Mining. Also a lot of guidance products available there on all of these challenges. The issue though is that a lot is known about what is possible to do, but implementation on the ground tends to still be the challenge. So the pressure from civil society, pressure from local communities to put in place some better ways of governing these issues is a important and key driver for getting those good outcomes on the ground. If you don't have that pressure, then you tend not to get the increased performance that we're all looking for. Okay, question 4. What are some of the new technologies in oil and gas production processes? What technologies can oil and gas producers focus on to become environmentally friendly in their process of exploration and production? This is a really good question. In the modules, we talked about some innovations in the production process of oil and gas that have changed the industry. We talked about directional drilling and shale gas and coal seam gas, and how that's opened up a whole new resource and a whole new industry in addition to the conventional oil and gas extraction from traditional, more permeable and porous reservoirs. So there's been already a technological and production shift that has really changed the way that the industry is perceived and its impacts. But there's also, I think, potential for using new innovations to address some of the main environmental challenges. And looking at the shale gas and coal seam gas revolution, some of the big environmental challenges there around water, the extraction of water from reservoirs that are the gas is associated with, and that pumping of that water and the treatment of that water tended to be into evaporation ponds. So there are some new forms of re-injection and also desalination of that water that could lead to better outcomes than those evaporation ponds. We've seen that there's in the directional drilling that's kind of led to the revolution in those in shale gas and coal seam gas. There have been some innovations where there wouldn't need to be so many wells drilled, because you can have a central well and then directionally drill out from that well, so you can have a smaller surface footprint. Interestingly, and this also applies to conventional oil and gas, some of the most innovative or interesting new technologies are around how to deal with methane emissions. So methane emissions are associated with the extraction of oil and gas. They're sometimes called fugitive emissions. They escape from pipelines, they escape from the wellheads, they escape because you're having to flare because you haven't got your compression and transportation right. So there's ways in which you could address that, and methane, as you know, probably know, is a much greater impact in terms of greenhouse gas intensity than carbon dioxide. So some of the technologies we're talking about that are green completion of wells, having better compressor maintenance, making sure you're monitoring the leaks that are coming with the facilities. So there are new technologies that are available to incrementally improve on oil and gas performance, but most of the emissions, of course, are from the burning of the product. So that's where the big challenge is. And despite the fact that people have been talking about for a long time now ideas of carbon capture and storage, that still hasn't been proven at scale. And you know, there are some questions over to whether that kind of technology system can actually be a realistic prospect for reducing emissions from the oil and gas sector. Okay, question 5. What opportunities are there for oil and gas and mining companies to work with government to initiate and execute public-private partnerships? Very good question. The first thing that comes to mind is obviously infrastructure. when you build a mine or you build an oil and gas facility, that facility requires infrastructure around it that can service that project, but also has the potential to service other industries in the vicinity and also service the society at large. So that the potential for shared use infrastructure is a big one. And if you have good coordinated planning, ports, railroads, roads, electricity generation, water facilities, these are the kind of things that with some good design, you can make sure that the capacity that is installed is enough to meet the needs of the project, but also the needs of other industries and the society at large. So that is an area that there's been some good research on, and I'd encourage you to look at the work that CCSI has done on shared use infrastructure. The other area is probably around having good agreements between projects and local governments, or perhaps provincial and national governments as well, and making sure that those agreements talk about how the governance arrangements for the project are going to proceed. That is a form of public-private partnership, because you're coming together to collaborate on the performance of that project. Okay, so question 6, and this is the final question that we have from our participants in the MOOC for this week. Excuse me. What is going to be the key conversation at COP22 that you think will be essential for the sustainable development of the extractives industry? So COP22 is coming up mid-November, only a few weeks' time. It's obviously following on from the Paris Agreement, and we now have the requisite number of countries signing on to the Paris Agreement that implementation will start happening. And coinciding with COP22, we've actually seen a number of key mining and oil and gas companies come out and endorse the Paris Agreement. So examples might be Lafarge-Holcim, which is the largest cement producer in the world, Rio Tinto, and Shell. So these are companies that are coming out and supporting the Paris Agreement. Obviously, the implications of the Paris Agreement are going to be that there's going to be necessity for example, the production of cement to result in less emissions than currently are being made. Cement production actually is a emitter of emissions. So there's a lot of work to do in the sector to have a serious agenda, but we are seeing companies come on board slowly to sign on to that agenda. The other thing I'd mention is another issue that's going to be discussed a lot at COP22 is around climate change adaptation. And obviously the mining and oil and gas sector is a producer of emissions, but in the instances that we do have significant changes in our climate, they also can be impacted by increasing droughts, increasing natural disasters such as floods. And we have seen places like Queensland in Australia in 2011, we had a huge flood event where the majority of the mines of the state, there's about 50 or 60 mines in the state, were flooded from that flooding event, and discharge of salt water from those mine sites because of the flooding led to some acute issues in rivers and streams. So it's not just an agenda for reducing emissions of production or the use of the product, it's also an agenda, I think, for having better planning around natural disasters, better planning about what we do to make sure that as sites don't discharge waste materials during these events. So I will leave it there. Thank you very much for your interest in the modules. Thanks for writing in your questions. I'm happy to answer anything offline as well. You can search me on the internet, read some of my work, and happy to share what we're doing at UNDP and what others have done in the past. Thank you very much, and enjoy the rest of your course.